In this video, we're going to go over saturation tests as well as naming and drawing cycloalkanes and cycloalkenes. So for the saturation test, essentially what we are trying to test for is whether or not the compound that we are testing is saturated or unsaturated. Okay, so as a quick reminder here, unsaturated means that the compound has at least one double or triple bond. And that'll be a double or triple bond between two carbon atoms. Whereas saturated, or a saturated compound, is only going to have single carbon-carbon bonds. Okay, so the saturation test tells you whether the compound that you're looking at is either unsaturated or saturated. And there's two versions of this test. So one that uses bromine and the other one which uses potassium permanganate. So in the first one, which uses bromine, okay, you can use it to do the saturation test, and normally bromine is a orangey or dark reddish brown color, and when bromine is mixed together with a saturated organic compound, the bromine is going to stay this orange or reddish brown color. And the reason being why this happens is because there's nowhere for bromine to attach to. Okay, so in other words, there's no double or triple bond for bromine to attach to, which would then change the color. Okay, but if bromine is mixed together with an unsaturated compound, there are those double or triple bonds present, which means bromine can attach to it and the solution will change from that orange color to colorless. Okay, so it's important that you know what the results of this bromine saturation test is going to be. Okay, the other test is going to be with potassium permanganate, so KMnO4, and by itself, potassium permanganate is purple, and when we use it in the saturation test, if you mix potassium permanganate with a saturated compound, it's going to stay purple, but if you mix potassium permanganate with an unsaturated compound, it's going to change from purple to brown. Okay, so make sure you know what the results of both of these tests are going to be. Okay, so looking over here, okay, this is just a more visual way to say what we just said. So bromine by itself is this orange, dark orange, reddish brown color, and in solution A, there was an alkene present, or even if it's an alkyne. So alkene is an organic compound that has a double bond. Alkyne are organic compounds that have a triple bond, right? And so these are going to be unsaturated compounds, okay, which gives you the result of a colorless solution when mixed with bromine. Okay, but if you mix bromine with a saturated compound, so an alkane, it's going to stay brown or orange, however you want to call it. Okay, similarly with potassium permanganate, so by itself it's just purple. If you mix it with a saturated compound, so an alkane, such as an alkane, just keep in mind alkanes aren't the only type of saturated compound you can have. Okay, it's going to stay purple. But if you mix potassium permanganate with an alkene or alkyne, which are unsaturated compounds, okay, potassium permanganate is going to turn brown. We just need to do some coloring here. There we go. Okay, so below here is like a question that you can give it a shot and predict what color bromine will be after being mixed with each of these compounds. Okay. So moving on to naming cyclic compounds. Okay, so cyclic compounds are just carbons that form a ring. Okay, we're going to start off with cycloalkanes, and we're going to focus on how we name these compounds because that's typically the harder of the two skills, naming versus drawing. Naming is the harder one, but please know that you're going to be expected to know how to name cycloalkanes as well as cycloalkenes, and you're going to have to know how to draw both of them as well. Although for these notes, they do focus on naming because that's the harder skill of the two. Okay, so first things first, the general formula for a cycloalkane is going to be CN and then H2N. So you're going to have double the amount of hydrogens compared to carbons there. And for our naming rules here, okay, you're going to use the ring structure as the parent chain. And the general template for naming cycloalkanes is you're going to start off the parent name as cyclo, and then the prefix that tells you how many carbons are in the ring, and then you're going to end it with ANE because ANE just means that you only have single bonds. Okay? So, for example here, we have cyclobutane. Okay, so the cyclo part, that's telling you that you have a ring. The bute part is telling you that there's 4 carbons in that ring. And then the ANE ending is telling you that there's only single carbon-to-carbon bonds present. Okay. Doing the same thing over here. All right. So we have cyclopropane. So again, cyclo just means you have a ring. Prop means that you have 3 carbons in that ring. And ANE means that there's only single carbon-carbon bonds. Okay, so just as a quick reminder here, if you're looking at these line diagrams and wondering where the carbons are, they're where each of those 2 sticks meet. essentially. So when you're looking at line diagrams, the carbons are going to be located either at the end of a stick or where two sticks meet. Okay. So for example, there's a carbon there, there, and there. So that's why I'm saying, yep, there's 3 carbons here. In this other example, the carbons are here, 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 and here. For practice with deriving chemical formulas from looking at line structures, this one would be C4. And then for the amount of implied hydrogens, remember that carbon always forms 4 bonds. So each of these has 2 implied hydrogens for a total of 8. Okay, with this one here, okay, once again, each carbon likes to have 4 bonds, so each of these carbons are going to have 2 implied hydrogens for a total of 6. Okay, so the formula for this is C3H6. Okay. So if there are branches on your cyclic compound, you're going to number the carbons in the ring so that the branches get the lowest possible number sequence. Okay. Okay, so if your cyclic compound only has 1 branch, you don't need to specify the number of carbon that that branch is on. Please keep in mind this is only for cyclic compounds. Okay. Otherwise, you should always be mentioning the carbon number that the branch is on. So it's only for cyclic compounds and only if you have 1 branch. Okay. If you have more than 1 branch, you're going to want to make sure to alphabetize the branches, and you're also going to want to make sure that you give the lowest number to the alphabetically first branch. And actually, I should add on to this. So you're going to give the lowest number to the branch that alphabetically comes first if, no matter which way you number your carbons, you get the same result, like you use the same numbers. Okay, so that's an important distinction that we need to say. So if regardless how you number carbons, you get the same result. Okay, so looking at our first example here, okay, so our parent chain is right here. And locating our branches, they're right there. Okay, so our branches, we have a methyl branch and we have an ethyl branch. Okay, so we know we gotta list our branches in alphabetical order, and if I number these carbons, so making sure that we're gonna be using our lowest numbers, I'm gonna start here, so 1, 2, 3, 4, 5, or alternatively, you could go this way. So you could go 1, 2, 3, 4, 5. Now, see, in this scenario, it doesn't matter if you use the pink or the purple numbering, your branches are still either on carbon 1 or carbon 3. Okay, so that ties back into this whole rule about, okay, you got to give the lowest number to the branch that alphabetically comes first, regardless of, or if regardless how you number your carbons, you get the same result. So that's the situation we're in here. Regardless of how we number, our branches are still on either carbon 1 or carbon 3, or carbon 1 and carbon 3. Okay, so that means I'm going to give the lower number to the branch that alphabetically comes first, which is ethyl, okay, or the branch that has 2 carbons, because eth means that they are 2 carbons there. So I'm going to go 1 ethyl, so it means the ethyl branch is on carbon 1. Okay, now we want to talk about the methyl branch. So dash 3 methyl. Okay, so now that we're done talking about the branches, we got to talk about the parent chain. Just as a reminder, the YL suffix is very important because that denotes that you're talking about branches here. Okay, this part tells you how many carbons in each branch there are, and this part tells us which carbon that the branch is on in the ring or in the compound here. Okay, so talking about the parent chain name, okay, because it's a cyclic compound, we got to go cyclo. Because there's 5 carbons in the parent chain, I'm going to go pent. And because there's only single bonds in the parent chain, I'm going to end it with ANE. So this is 1 ethyl, 3 methyl, cyclopentane. All right, example number 2. So I'm just going to highlight where my parent chain is, which is right there. And it looks like we've got 2 branches here, 2 methyl groups. Okay, so with numbering my carbons, I could be going like this, 1, 2, 3, 4. Okay, or alternatively, right, I could be doing 1, 2, 3, 4. However, let's just look at the numbers we're using. So both of them have one of the carbons, or sorry, one of the branches on carbon 1. Okay, so the purple numbering, our branches are on carbons 1 and 2, versus the pink numbering has branches on carbons 1 and 4. Okay, so we're going to use the one that gives us the lowest overall numbers, which is saying that we have branches on carbon 1 and 2. Okay. Okay, so we've got our branches on carbons 1 and 2, and in total we have 2 methyl branches, so I'm going to have to say dimethyl. So the di just means we've got 2 of the methyl branches. Okay, and now that we're done talking about the branches, we need to talk about the parent chain. So because it's a cyclic compound, I gotta go cyclo. Because there's 4 carbons in this ring, the prefix or the stem name, whatever you want to call it, is but. And because there's only single bonds, ANE. So 1,2-dimethyl-cyclobutane. Okay, so as I said, the notes do focus more on naming rather than drawing, but that's because it's the harder of the 2 skills, but you will be expected to be able to name as well as draw cycloalkanes as well as cycloalkenes. So let's move on to cycloalkenes. So the general formula for them is CnH2n-2. So basically what that means is you'll have a certain amount of carbons, and then with the amount of hydrogens, you'll have 2 times the amount of carbons subtracted by 2. Okay, so the double bond is always going to be between carbons 1 and carbons 2 in cycloalkenes. So that's why we don't have to put the number in. Okay, so this is very specific for cycloalkenes. Okay, so just know that. For just alkenes, so not cycloalkenes, just alkenes, if the double bond is on or starts on something other than carbon 1, then you would have to specify which carbon it starts on. Okay, but for cycloalkenes, you always put it so that the double bond starts at carbon 1 and is in between carbon 1 and 2. Okay, and the branches get the lowest numbering sequence after the bond. The template for cycloalkenes is you're going to start off with cyclo. You're going to use the prefix that tells you how many carbons are in the cyclic compound, and then you're going to make sure to end with the ENE because this specifies that we have a double bond. Okay, you're also going to list the branches in alphabetical order, okay, with the number of carbon that they're on. All right, so let's do this one here. Okay, so we have 6 carbons in this ring. Okay, and it really doesn't matter if you number your carbons this way versus this way, okay, because both ways have the double bond in between carbon 1 and carbon 2. Okay, so with talking about this, because it's a cyclic compound, I have to start with the word cyclo. Because there's 6 carbons in the ring, I'm going to use the prefix hex to mean 6 carbons. And then because there's that double bond, I need to write ene. So you could write this as cyclohexene, or you could write it as cyclohex-1-ene if you really wanted to specify where that double bond is. However, if there's no number written, you assume that it starts on carbon number 1. Okay, so both of these are correct. You can use either. With example number 2, okay, we've got a cyclic compound. There's 3 carbons in it, okay, and we can number our carbons like so. So this is going to be cyclopropene. Okay, or if you really wanted to say it as cycloprop-1-ene. Nope, that's getting a little messy. With this next one here, just going to highlight the parent chain. Okay, there's our branch. Okay, so with this, with numbering our carbons, obviously we want our double bond to start at carbon 1, but we also want to make sure that the branch gets the lowest number possible as well. Okay, so because of that, okay, and because the double bond has to be in between carbon 1 and 2, our options are we could do 1, 2, 3, 4, or we could go 1, 2, 3, 4. Okay, so both options have the double bond between carbon 1 and 2, but notice how The purple numbering way has the branch on carbon 3, whereas the pink numbering way has the branch on carbon 4. So we want to use the purple way of numbering the carbons here, okay, because that gives us the lowest number. So let's just make sure to write a note here. Okay, so double bond must be between carbon 1 and carbon 2, but make sure that branch gets lowest possible number. Okay, so in this case, what this is going to mean for us is for our branch, this is 3, because there's 2 carbons in this branch, eth, and then the YL just means that we're talking about a branch. Okay, so 3 ethyl, and then now we got to talk about our parent chain. So it's a cyclic compound. I got to start the parent chain name off with cyclo. There's 4 carbons, so bute. And then because there's that double bond, ene. So we could do it like that, or 3 ethyl cyclobute 1 ene. Either or. Okay, with this next example here, so highlighting the parent chain, and then my branches are here, here, and here. Okay, so remember that you need to be listing your branches alphabetically. That's a key small detail to remember for your branches. All right, so for numbering our carbons, okay, we could go like this, or we could go like this. So you always want to make sure that your double bond is between carbon 1 and carbon 2. Okay, so with the purple way of numbering, our branches would be on carbons 1, 3, and 3, because there's 2 branches on carbon 3. Or our branches could be on carbon 2, 4, and 4. Okay, so if we look at these, we want to make sure we're using the lowest overall numbers. So that means we need to be going with the purple way of numbering these carbons. Okay, so our branches here, okay, remember we got to list these alphabetically. So that's why I'm going to be talking about the ethyl branch first, even though it's not on carbon number 1. Okay, so 3 ethyl, and then now we're talking about the methyl branches, and I'm gonna list the numbers in numerical values. So whatever you do, don't go 3,1 dimethyl. You need to list it as 1,3 dimethyl, and then that's going to be cyclobutene. Okay, so just remember that the die is pretty easy to forget too when you have a total of 2 branches of a certain type.